So today we're moving on to other types of polygons besides just triangles. And we're going to be working on the sum of interior angles in polygons and how to find missing angles, which kind of moves naturally from what we were doing with triangles before. So, we have these triangles and we're missing an angle, and we learned that there are 180 degrees in a triangle. So if I add up the angles that I do have, 40 and 45 is 85, and then subtract from 180, then that gives me the missing piece, which is 95 degrees. So that angle is 95. So again, I have 2 out of the 3 angles, and I have 155, 127, plus 28 is 155 out of 180 degrees. So to find the missing part, I just subtract, and I end up with 25 degrees for that missing angle. Would the angle measurements 46, 52, and 90 make a triangle? The quick answer is no. 0, 2, and 6 would make 8 as the last number, and a triangle has to have 180, so 0 has to be the last number. So I can very quickly say no, but I can also add them all up just to make sure. 46 and 52 is 98. And 98 and 90 is 188 degrees. So too big to be a triangle. Our objectives are that we will use diagonals to divide polygons into triangles, determine the sum of the interior angle measurements of polygons, and find missing angle measurements in polygons. Kids should still be working on their quiz prep packet. That quiz is on Thursday or Friday if you're in 4th period. Alright, so the first thing is we're going to measure some triangles, which the kids should be pretty used to. I give them all protractors, and what I ended up doing, after a little bit of trial and error, was assigning each group one of the triangles to measure the angle measurements for. And then they just find the angle measurement, which in this case is 30 for this one, and then 30 for this one, and it's not on there exactly right. Oh, there we go, 120 for the top angle. And there is some human error in these. Like this one I remember was a very neat one, and was easy to do 120, 30, and 30, and get 180 total. But some of them are less neat, and we don't end up with exactly 180, which is fine, because we're not perfect when we make our measurements. Like this one I would say is 90 something, maybe 98 or 99. We're going to go with 98. And then this one over here is, I'm going to go with 28. And this one up here is, well, it's acute, so we're going to go with about 53. And when I add that up, these two together make 70, 81, and 81 and 98 make 179. Alright, last one. This one is about 27. And then we have about, it's not quite lined up, is it? We're gonna go with 99. Oh, that's acute, not 99. 81. And then up here, about cute, about 72. Alright, so 72 and 27 is 99, and 81 is 180. That one worked out very neatly. And then when I add all of these together, 180 plus 179 plus 179 plus 180 is 539. I got varying amounts in class with the kids, usually somewhere around here. The most I think we got 550 once, and that was the biggest. Alright, so what I'm going to do is take a little clipping of this so that we have it on the next page to compare. And then I'm just going to paste that. Paste. Move this down so we can see it. There we go. Alright, now we actually, I had the kids, one of the groups was also measuring the angles on this one. We're going to just measure them ourselves really quickly. This was the most challenging because you got to know which ones to measure. We're just trying to measure the angles of the actual pentagon. So this one is obtuse, so maybe 99. I'm going to go with 99. And then this one is obtuse, and it's about, oh, that's a tough one, 108 maybe? I'm going to go with 108. And then this one here is about, let's see, that is obtuse, so it's maybe 103. And these are all obtuse, just so that I don't have to keep saying that. There. That's about 120. Oops. And then get on there. This one is about 102 or 103. Something like that. Alright, and then I can add all of these up. So how did we create this shape? Let's go back to this and see how I created that shape. Well, I actually made it out of these triangles. Oops. This thing is very finicky about you getting placed. Anyway, there we go. There's your pentagon. It's the same exact shape. So I could have just said, well, of course that's 120. This probably should have been 98 because it was 98 up here, but I don't know, maybe it was 99 because we were a degree short. We'll see. So we created it by stacking the triangles that we already had. Record the measurements. I'm going to add them up. So we have 102 plus 120 plus 103 plus 108 plus 99, and we get 532. I'm clearly missing a couple of degrees in here, but that's about 532, which is close to what we had up here. I just made a couple of mistakes. If I fill in the measurements from up here, this is 30, and this one 72. I should have gotten 102 here. And this is 30 and 27 and 53 from up there. So I should have gotten, that would be 80, 110. That's where I made my mistake, right there. And that should have been 98, 99, and then this one should have been 81 and 28, which is 109. So close. We find the sum of interior angles in a polygon by using diagonals to divide it into triangles. And I'm going to start using shorthand to divide it into triangles. Then multiply 180 degrees by the number of triangles that you get. So if I do 180 for each triangle, 180, 180, 180, times 3 triangles, that's 0 times 3 is 0, 3 times 8 is 24, and that would be 540, which this one would be, this is really a lot closer because the measurements were more accurate, but this is still really close. So a diagonal is a line segment that connects two non-adjacent vertices, or corners, or points, of a polygon. When we use diagonals to split a polygon into triangles, they should always start at the same vertex and never cross. Now, diagonals can cross in certain instances, just not if you're trying to split a polygon into triangles to find the number of degrees in the polygon. But we're going to find in our next lesson that there's some interesting use for diagonals that do cross. So, for right now, we name each shape, then divide it into triangles using diagonals, and then use the number of triangles to find the sum of the interior angles of the shape. So this is a rectangle, and if I'm going to start all of my diagonals at A. So from A, I can get a diagonal that goes to C on this one. I can't go to B because that's a side, and I can't go to D because that's a side, so that's the only one I can do. So that turns it into 2 triangles, so we do 2 times 180, and we get 360 degrees total. Alright, this here is a trapezoid. And I'll do the same thing. From A, I can only go to C. So that's still 2 triangles and still 360 degrees. And then here we have 5 sides, so a pentagon. And from A, I can go to C, or I can go to D. That makes 3 triangles, which we already did before. When we did our pentagon from our example, that was 540 degrees. So a pentagon always has 540 degrees in its interior angles. Alright, this has 6 sides, so it's a hexagon. And it can be split from A to C, from A to D, and from A to E. So that makes 4 triangles. So 180 times 4 is going to be 720. And then here we have 7 sides, so that's either a septagon, or you can just say a 7gon, because it's far less common, and if we don't know the official name for a shape, we just say the number of sides gon, like 13 gon, or a 26 gon. So if we split this one up, then we get A to C, and D, and E, and F. 1, 2, 3, 4, 5 triangles, which is 900 degrees, 180 times 5. Alright, this here has 8 sides, so it is an octagon. And there's a pattern here. It's always 7 sides, 5 triangles, 6 sides, 4 triangles. It's always because there's always 2 points, the 2 closest points that you can't connect to, so 2 less triangles than there are sides, so this one should have 6 sides. 6 triangles, I'm sorry, because it has 8 sides. There we go, 1, 2, 3, 4, 5, 6. So 6 triangles is 1080 degrees. 900 plus another triangle, another 180. It's 1080. So we can find a single missing angle for any of those polygons. But for today we're going to focus on triangles and quadrilaterals, because those are the bulk of the focus in this unit. So it's the same as when we did triangles, except now it's 360 degrees total, because it's like 2 triangles. So 360 degrees for a quadrilateral minus the sides that we do have. Well, we have 95 and 95 and 102. So that's going to be 190, 292. And then I subtract 8, 5, 15, 6, 68 degrees. 68 degrees for that little x there. Same thing here. It's going to be 360 minus whatever I get when I add these up. 102 and 101 makes 203, and 203 and 59 makes 262. So I subtract 262, and I get, that's 8, that's 9, 98 degrees. Same thing here. Let's break out the calculator, since you're allowed to use a calculator on the test anyway. I'm just going to do 360 minus 75 minus 106 minus 103. And I get 76 degrees. That's another way you can do it. You can just start at 360 and subtract each side one at a time if you want to. This one is 360 total, take away the 116 degree angle, take away the 72 degree angle, take away the 88 degree angle, and you get 84 degrees. 360 degrees minus 101 minus 97 minus 73 is 89 degrees. And 360 minus 99 minus 93 minus 114 is 54 degrees. Triangle, same as before, 107 and 37 is 144. So this should be 36 degrees, because 180 minus 144 is 36. 67 and 56 is 123, and 180 minus 123 is 57. And then there's just some practice here to go ahead and attempt. This is, theoretically could be a very short lesson. It hasn't really been so far. I'm hoping that it will be with 4th period, because there were a lot of students missing on Friday, so it would be helpful to have time to go over what they missed. But we'll see. Keep working on that quiz packet.